Hey guys, thanks for watching the video. What we're going to be doing in this video is demonstrating how to add an additional hardware output to an NCE or an FEC controller using the controller configurations tool from Johnson Controls. To give you a little bit of a background on this system and why we are having to add this point, this control point is going to be used to control an additional steam valve. The original system had a single output controlling the air pressure by using an electro-pneumatic transducer. I'll put a link down in the description to my video on electro-pneumatic transducers to give you just a little bit better understanding of them. Anyways, the basic overview is that single output, it was an analog output, would swing the signal on the EP. The EP would then change the air pressure, the pilot pressure, to the control valves. Each of the control valves were also equipped with a pilot positioner. These pilot positioners were adjusted to where the valves would be staged. The first valve, the 1/3 valve, would be staged to operate between control pressures of 0 psi to 10 psi. The 2/3 valve would be staged to operate between 10 psi and 20 psi. That's how that system worked initially using a single output. However, as time has passed, the original steam valves, we've had one of those to fail, so the steam valves both were upgraded to a new electronic controller. New valve, new actuator that is electronically controlled, and that way we're getting rid of the pneumatics. That's a maintenance problem, that a way to reduce our maintenance, and by getting rid of some of the pneumatics, and a little more efficient. And the program will need to be changed, and the additional point will need to be added, because instead of having a single output controlling both of those valves, we now need two analog outputs, one to control the 1/3 valve and one to control the 2/3 valve. Now, this video is going to demonstrate how to add those points within the software. We're going to be reusing one of the outputs that's already there. However, we do have to modify the programming. Anyways, just stick around and I will demonstrate how this is done.
Here is our original control program. I recommend that you make a backup copy of this program, of your original, before you make any modifications to it. We're going to add the analog output here, and it's a very simple process. You can see here, I'm going to show you that we have the hardware points available. I'm looking at the hardware point for this particular program already. You can see that I have several outputs and inputs available on this particular system. There are quite a few IOMs, and the output that we're going to add is for this one right here. We're actually going to use a 0 to 10 volt output that is in this system. So the way that we're going to do that is we're simply going to go over to outputs. We're going to right click, and we will get this pop-up window, and this is where we can select the type of output that we're going to add. I am going to click here on the analog type, and that's going to put all of these in order by analog. I'm also going to click here, and I have all of my 0 to 10 volt outputs that are available within the system. Now what I'm going to do is to go down here, scroll down, and I'm actually going to find the one that's labeled for the heat exchanger. This is, there's quite a few of them here, so you may have to scroll back and forth. You can do searches to make it a little quicker for you in the system, but I'm just going to scroll through here and find the one that I want. And right here it is. This is a point that we're going to add, and what we do here is we simply click. It gives us this pop-up window. We simply press up because it's just one output that we're going to add, and then we press the finish button. and there's a next button, and it will create that output in the window, and you can see it here. Currently, it is not tied to any specific hardware. We can go in here if we were going to do any kind of modifications to it as far as changing the direction. We're going to change the name to a little something easier to recognize, kind of match what the system is going to be doing with this, what we're using this output for. It'll make it a little easier when we pull the point into Metasys. It'll also make it a little easier when we add some of the custom programming that we're going to have to do. And once you make any changes within here that you see is necessary, you can review here, min, out, your engineering values, min, out, max, out, that sort of thing. And that's where you would change any of that. You can change the polarity, the direction of travel from here. We hit save or apply, and once we do that, we hit the done. And now then, you can see once again, here is our output. This output has got to be configured. It has to be, assigned a specific hardware point. Okay, here's the output that we have just added. What we're going to do, I'm going to scroll down here. The system will try to automatically place your outputs or inputs where it thinks you want them. You can move them around. It's a simple drag and drop type thing. It's very simple to do if you need to move to a different input or an output hardware point. And this system makes it quite simple. So I highlight the point that I just created. I press the right arrow button, and you can see that it populates it on the system exactly where we want it to. And that is where we will be landing the wiring for that. So I'll close that window out, and what we've got to do is modify the control program. I'm going to maximize this screen just a little bit, and this is the logic block that controls the hardware outputs. What we need to do here is to view the logic, and this is going to bring us into the inner workings of that logic block. This is where we have got to modify. Currently, this is tied to just a single output. Now, the way that we know which logic block that it is linked to, we're going to look at our original output. If I hit the right button, this is the original output. This is what we're basically wanting to replicate. We're going to be reusing this particular hardware output. And I'm going to right click, I'm going to select show involvement, and this tells me every logic block that is involved with that output. And of course, output control, this is the one that we need. That's how you know which program block to modify. So we go back in here to view the logic. This is the original output point. We'll show you how to connect the software to that point momentarily once we get this done. But this is the original one. This is the one that is currently running in the system. It is actually, if you go up here, if I click on the connections tab, you can see here, this is my output, and you can see that it is connected to that particular point within our logic. That's why naming of your logic points can make it a little easier for you when you're modifying a program. So we're going to go back in here. I'm going to bring this back up. The first thing that we've got to do is we have got to break this connection. This is the connection to the PID loop that runs this system. That PID loop is what does your comparison between your set point and as well as the actual. So I'm simply going to click on it, hit delete, and it's going to ask me if I really want to do that. Yes. And now I have that connection broken. Now, we have got to create a couple additional points within this logic system. I'm going to rename this one to make it a little easier for us to see what's going on. I'm just going to call that the 1/3. And what I need to do is I need to create another one of these outputs. So I'm going to go to my output folder. I need a floating output. So I'm simply going to grab it and I'm simply going to drag it over to my screen. And once I drag it to the screen, I can populate it. I can put it wherever I want it on my screen. I'm going to give it a common name as well. I'm going to call this one the 2/3 valve. That way it make it a little bit more clear on what's going on when we do this programming. Now then, a couple of other things that I've got to have is I need a couple of span blocks. And of course, once again, that is going to be over here on the left-hand side of the screen. We just got to find the correct folder. There's quite a few options that we have, quite a few logic blocks that we can grab in here to modify the system however we need it. Underneath this one, here is the span block that I need. I simply click it, I drag it out, and there is one of them. It's going to take two for what we're doing for this. I'm going to come back over, I'm going to grab another one, I'm going to pull it over here as well. And I'm simply going to drop that in place. Here are the two span blocks. Now I'm going to connect each of those span blocks to the output of this PID loop. You can see how my mouse changes, and once it changes I click and then just drag to the input of that first span block. When it changes I just click again and it connects it. I do the same thing again. I come down here, I click and I make the next connection to my other span block. I'm going to pull this down a little bit closer here just to make them look a little neater. That way, if you ever have to come in troubleshooting, once again, I get my little magic wand and I click, drag to my output. Once again, click, drag, and there are the two bits in the program connected. Here is the first span block. What we have got to do when the output of that PID loop is at 50%, we want the valve actuator to be at 100%. Since this is a 1/3, 2/3 valve, we want that 1/3 valve to be 100% when that PID loop has a 50% output. So what I do here is I've got to change this span block just a little bit. What I'm going to do here, where we currently have 100, I'm going to change that to 50. That is my output or my input high range. Once that PID loop, once again, that PID loop hits 50%, that valve should be at 100%. And that is controlled by this output range here. And once we have that done, I hit apply and then I close it out. And now I've got to go back and I've got to change the other one. This is going to be just a little bit different. Instead of this valve moving, I do not want this valve to move until the output of that PID loop reaches at least 50%. Okay, this is the 2/3 valve. It does not need to move until we get at least to half of that PID loop's maximum value. What I'm going to do here, the input range low, I am actually going to change that to 50. That means the output for this one will not move that 2/3 valve until the PID loop output reaches at least 50%. And once it goes between 50 to 100%, that 2/3 valve will move between, from 0 to 100%. Now that we have that done, this is going to be what controls those two outputs. It's not that complicated once you get it figured out, but those two span blocks, the first one is going to span that first valve. It's going to control that valve based upon that PID loop output, and the second span block will control the next one. Okay, the next step that we have to do is we have got to connect those logic blocks to the output itself. All right, as of right now, that output, as you can see here, there's nothing connected to it. We have not connected that hardware output that we created to anything within our logic system. That is what our next step has got to be. It does not do us any good, even though we've created that bit inside the programming. It does not know where that information is going. We have got to tell it exactly where we are going to put that information. So, without it being connected, it will not work. So what we do, I'm going to right click, I'm going to select Make Connection, and here is all of the points within this program. You can see here that we have quite a few points. Now then, we can go here to, here's our logic section, and you can see that there's just anything within our program. You can see right over here, our output control. Here is that tab here, output control. Everything under here is part of the output control. So what we need to do is we're going to have to drill down and find our heat exchanger output. Now then, you'll notice we do not have that heat exchanger output in this particular section when we're looking at it. But if you look over to the right just a little bit, you'll see that it's there. Sometimes this system, I'm not exactly sure why, it must just be some kind of a glitch in the programming. It will not necessarily populate the blocks the way that you want them to. So what we need to do is we're going to have to go with this a different avenue. Instead of being able to go into our heat exchanger block and make a connection there, we're going to do it just a little bit different. We could connect it by going up to the output that we created from here, simply selecting that output, making the connection, but it will probably be a little easier if you're going to make a connection within the system by going to the output first, because you can see here very plainly, once I click all through these, I'm not seeing that output. The reason is I selected to make a connection on the block, on this particular logic block. So it does not display the one that I selected. So don't let that confuse you. So now I'm going to highlight the particular output. I've got that highlighted. I'm going to come down here. I want to connect that output to this logic block. This is how we're going to make our connection. I highlight this here, and I come down to the connections window, and what I'm going to need to do here, you'll see that there's nothing here currently, but after we make the connection, you'll see it here. I'm going to come over here, I'm going to right click, make connection. Now once again, I have the output highlighted. I come over to my pop-up window. Now this time we have the output selected. I'm going to scroll down, and you can see here once again, here is all of the information underneath the logic block. And I want you to look here, heat exchanger output control. See, now when I selected it the first time and tried to make the connection, it was not there. I could have gone up, connected it to the output itself, but this just kind of for demonstration purposes, we'll do it like this. Now I'm going to highlight that. It's going to populate this side. Here is that second logic block that we created right here, the 2/3 that we created in logic. Once I highlight that, I hit OK, and you'll see it make the connection, and here it is. We are now connected to that output. We have that output once again assigned to the output 15 on our controller. We go back in here and look. We hit the point assignments. We scroll down, and sure enough, that logic block is going to control this output. That output 15, we will be able to control our other valve, our 2/3 valve, from that. It's a very simple process. Follow a few basic steps, and you can easily modify your program to do virtually the same thing as this.
Guys, I hope the video was helpful to you. I would appreciate it if you would give it a thumbs up. Also, be sure to subscribe if you haven't already, and leave me any comments down below. I love trying to respond back just as quick as I can to any questions that anyone has. And also be sure to visit my blog at systemcontroltech.com. Thanks for watching.